Good day, my name is Richard and a warm welcome to Tutoring with Richard, where we cover the South African school syllabus and native topics. If you find these videos helpful, please consider supporting me on PayPal, Patreon or Buy Me a Coffee. Links in the description box below. Today we're going to cover Mathematics in 6. The topic of this tutorial is a mixed bag of exam DP test questions. Round 5, question 5.5. The question is included in the video. And this is centers of pressure. We have been asked to issue a cautionary note. When doing these questions, please use the method I'm going to show you, as this is the method that is marked correct. Using your own method to answer questions could cost you marks, even though your method and answer might be right. See the cautionary note at the beginning of the video. On a side note, watch till the end of the video. If you watch only the first 5 minutes, you will not gain a full understanding of what you need to do. There is no quick fix in mathematics. It takes persistence, discipline and repetition. You have to use these steps in order to succeed. Let's get straight into it. Our question states, a vertical weir in a rectangular canal is 6 meters wide and 3 meters high. The top of the weir is 2 meters below the water surface. Now what we have to do now is make a neat sketch of the weir and show the representative strip that you will use in order to calculate the depth of the center of pressure. Now, to calculate the center of pressure, you have to do two things. You have to take first the moment of area, and then you have to take the second moment of area and divide one from the other. I will show you how to do that, and that will give you your center of pressure. Your center of pressure is always on the y-axis. So, for example, we are going to do a rectangular weir. So, here's how it goes. It goes like this. So, the weir, I'm going to do this way because it actually works out a lot easier if you do it this way. Always do it on top. Now, the weir is like this. It's directly in half. This is just positive 3, and that is negative 3, and over here is 3. So, what we need to do, and also it is 2 meters below the water surface. So here's the water surface up here, and that is at 5. That doesn't really come into account when we do these sums. Now, the only time it comes into account is when, so here is our representative strip. It goes through here. That's our representative strip. So from your representative strip all the way up is R. So that's R, and from there to there is Y. Now, R equals, in this case, 5 minus Y. So, what we're going to do now is, now that we have R, now we need to get dA, because our formula is 3 and 0, because yes, that is our mark. Now it is R dA. We have to work at dA. We have R, now we need dA. So dA is the formula you would use for your y-axis line. So in this particular case, it is, so dA is equal to 2x dy. So x is equal to 3, because x is equal to 3, because that is our line. When your line is straight across, it doesn't tilt or anything like that, there is no gradient. It is just the end number, it's just your constant. So x is 3, so dA is equal to 2 times 3 dy, which is 6 dy. So now we have our formulas. So the integral of 3 and 0 times 5 minus y times 6 dy. Now we can put these in line. So 5 times 6 is 30. So it's the integral of 3 and 0. So it's 30 minus 6y is equal to dy. Now we can integrate. This is the first moment of area. So this is 30y minus 6y squared over 2 when we've integrated. So we've integrated, got 30, 3 and 0. So now that we've integrated, so now we put 3 where there's y. So we've got 30 times 3 minus 6 times 3 squared over 2, which equals 63. And all this is minus 0. Because if we take this, put a 0 here, 30 times 0 is 0, 6 times 0 is 0, 0 divided by 2 is still 0, so we're done. So it's 63. So area moment is equal to 63. Now we're going to take the area moment. Now we're going to take the area moment, the second moment of area. We're going to take the second moment of area of this, and it is the integral of 3 and 0, 5 minus y squared times 6 dy. So now we've got to expand. We have to FOIL. So 5 minus y times 5 minus y. 5 times 5 is 25 minus 5y minus 5y. Y times y is plus y squared. So in all we have the integral of 3 and 0, 25 minus 10y plus y squared, all times by 6 dy. Okay, so 25 times 6 is 150, so 3 and 0, 150 minus 60y plus 6y squared dy. Now we can integrate. 150y minus 60y squared over 2 plus 6y cubed over 3. That's 3 and 0. So, what we need to do now to get our second area moment is put all this in. So, 150 times 3 minus 60 times 3 over 2 to the power 2 plus 6y times 3 cubed over 3. Now our area, second moment of area, is equal to 234. So now to calculate our centre of pressure is 234 over 63. So our second area moment over our first area moment. And this equals 3,714 units. And that is our centre of pressure. If you found this tutorial helpful, please give it a like and subscribe. It really helps with the algorithm and to grow the channel. Positive feedback is most welcome. I enjoy reading your comments. Please use the comments section to let me know what topics you would like me to cover in upcoming videos. Be at peace, be kind to each other, and remember, passing well is achievable. Have a great day. Looking forward to seeing you in the next video.